So hello everybody. Today we're going to be doing a nice differential equation. So which is written right here. So y prime is equal to y times 2x minus y squared, everything over x times 3y squared minus x. Now I'm just going to go ahead and expand this a little bit. I'll just rewrite this as 2xy minus y to the third power over 3xy squared minus x squared. And this is the same as y prime, which is the same as dy over dx. Okay, so from here we have that 2xy minus y to the third power times dx plus x squared minus 3xy squared dy is equal to 0. Now we can go ahead and say that this here is a function of x and y, we'll call it p, and this here is another function of x and y, we'll call it q. So we want to check if whether or not this differential equation is an exact differential equation. So in order to do that, the following condition must be satisfied. So delta p over delta y is equal to delta q over delta x. Now let's go ahead and check whether or not this is true. So delta p over delta y is the same as delta over delta y of 2xy minus y to the third power, which is the same as 2x minus 3y squared. As for the second one, delta q over the derivative of q with respect to x is the same as delta over delta x of x squared minus 3x y squared, which is equal to 2x minus 3y squared. So what we can see from here is that this condition is fulfilled, and therefore our differential equation is an exact differential equation. Okay, so how do we go about solving exact differential equations? The sole idea of solving exact differential equations is that we are searching for a function such that, we'll call it u, such that its partial derivative with respect to x is equal to p of x and y, and whose derivative with respect to y is equal to q of x and y. Okay, so from here we get that delta u over delta x is equal to 2xy minus y cubed. Okay, and from here we get that du is equal to 2xy minus y cubed dx. Now we'll just go ahead and integrate both sides. So we'll get that u is equal to, and remember, we're integrating the right-hand side with respect to x, is equal to x squared y minus x y to the third power plus a constant, but this constant won't really be a constant. It will be some function of the other variable. Let's call it phi of y. Now we're going to differentiate both sides with respect to u, not with respect to u, sorry, with respect to y, and we'll get that delta u over delta y is equal to x squared minus 3x y squared plus f prime of y. Now, we said that this has to be equal to q of x and y. So, if we remember, q of x and y is x squared minus 3xy squared. So, x squared minus 3xy squared plus f prime of y is equal to x squared minus 3xy squared, and these two parts can cancel out. So f prime of y, which is the same as d phi, whatever, over y is equal to 0. So that would imply that d phi is equal to 0. So phi of y isn't a function at all. It's just some arbitrary constant. We'll go ahead and call it c. Okay? So therefore, u, the function that we were talking about, is equal to x squared y minus xy to the third power plus c, or in other words, the solution to our differential equation is going to be x squared y minus xy cubed is equal to k, which would make k equal to negative c. So finally, this is our final solution to this problem. And maybe you could go ahead and try to explicitly write either x or y, but we don't have to do that. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one, and goodbye.